Determine the values of b and c such that the function h of x equals sine 2x for x is less than or equal to pi over 2 and bx plus c for x is greater than pi over 2 at the x-coordinate x equals pi over 2 will be continuous and differentiable. Let's start with continuous, which requires the limit as x approaches the x-coordinate of pi over 2 from both sides of h of x will equal h evaluated right at pi over 2. H of x here is a split expression function that happens to split right at the x-coordinate of pi over 2. So to work out the two-sided limit, we do have to work out the two one-sided limits separately. So we will have the left side of pi over 2 of h of x and the right side of pi over 2 of h of x. Let's start with the left side limit. The left side of pi over 2 means less than pi over 2. So from the split expression function, we will use this expression, sine 2x. Next thing, we can plug in the pi over 2 for an x. And we have the sine of 2 times pi over 2, which is 2 pi over 2, or just pi, so we have the sine of pi. Sine of pi is a 0. Let's work out the right-sided limit. The right side of pi over 2 means that we are greater than pi over 2, and we will use this for our expression. So we have bx plus c. Plugging pi over 2 in for the x gives us b times pi over 2 plus c. The last thing we want to evaluate is h right at pi over 2. So we use the expression where the pi over 2 is included, and that's this first one here. So we can plug the pi over 2 right in for the x, and that'll be sine of 2 times pi over 2, which is sine of 2 pi over 2, or just sine of pi, which matches the left-sided limit, and it also comes out to a 0. All three of these have to match each other for continuity. So we know that b times pi over 2 plus c has to match the zeros that we're getting for the other two. There's two unknowns in there, b and c, so we cannot solve it just yet, but we also are going to be looking at the differentiability of h of x here. So we're going to be looking at h prime of x. H prime of x is the derivative of h of x. The first expression, sine 2x, the derivative will be cosine, leave the inside alone, 2x, and then multiply by the derivative of the inside, which is a 2. We'll put it out front. And that's going to hold true for x is less than pi over 2. We cannot include the pi over 2 unless we know it's differentiable, but we are finding the b and c that make this differentiable, so we can include, because we're going to find the b and c to make this true. The second expression, bx plus c, with b and c being constants, the derivative of bx, constant times x, will just be the constant b. The derivative of c, a constant alone, will be a 0. And this will be true for x is greater than pi over 2. Differentiability is just continuity of the derivative, so we want limit as x approaches to pi over 2 from both sides of h prime of x needs to equal h prime of pi over 2. Since we have a split expression function, and it's splitting right at that x-coordinate of pi over 2, we will need to work out the two-sided limit from each side separately. So we will have the left side of pi over 2 of h prime of x, and the right side of pi over 2 for h prime of x. Let's start with the left side limit. The left side of pi over 2 means less than pi over 2, and therefore we will use this expression for h prime of x, 2 cosine of 2x. Plugging pi over 2 in for the x's, that will give us 2 times the cosine of 2 times pi over 2. So we have 2 cosine of 2 times pi over 2 is 2 pi over 2, or just pi. And the cosine of pi is a -1. Times that 2 gives us a -2. Let's work out the right-sided limit. The right side of pi over 2 means greater than pi over 2, and that means we will use this expression for h prime of x. B is a constant, and the limit of any constant is just a constant, so that will still be a b. And last of all, we want to evaluate h prime right at pi over 2, and that'll be using the one that includes pi over 2, and that's this first one here. We plug pi over 2 right in for x. We will have 2 cosine of 2 times pi over 2. So this will be 2 times the cosine of 2 pi over 2 is just pi, and the cosine of pi is a -1, and this comes out to -2, just like the left-sided limit does. And therefore it matches the left-sided limit, but we have to have all three of these match, so we know that the right-sided limit, which is a b, has to match the -2, that's the left-sided limit, and the function evaluated right at. So apparently b needs to be a -2. We can now take this result that we have for b and plug it back in up here to find c. So -2 times that pi over 2 plus c needs to equal 0. So -2 pi over 2 plus c equals 0. The 2's can cancel here, and we have -pi plus c equals 0. We can now add pi to both sides, and it looks like c comes out to